This video is sponsored by War Thunder. War Thunder is a realistic, free-to-play military vehicle combat game. It's available on PC, PS5, Xbox Series X, and previous generations of console as well. No need to purchase anything, just download and play. In this game, there are more than 2,000 historically accurate tanks, helicopters, ships, and other vehicles spanning the entire 20th century. They're all carefully built and incredibly detailed, operating in a realistic physics engine. It's an immersive gaming experience with real historical campaigns. Even the sound is amazing. And look, you could just jump in for a quick arcade game, which is great if you're pressed for time or just looking for something casual. I love a quick, easy, casual option. I'm a busy dude. I just want to jump in for a few minutes and have a little bit of fun, not something endlessly complicated. But you could also play realistic if you've got more time in your hands and go for the more challenging technical stuff. And for you hardcore folks, there's even Simulator, if you like getting destroyed. Right now, War Thunder is inviting all of you guys to join its 50 million worldwide players on the battlefield for free, by the way, using the link below. And for those of you that do jump into the game using that link, War Thunder is giving you a free premium tank, aircraft, or ship, plus 3 days of premium play for free. It's a cool deal. Thank you, War Thunder. And now today's video. The tongue map. If you've ever taken an elementary or high school science class, chances are you've encountered this classic of scientific illustration. A diagram of the human tongue neatly divided into zones showing the locations of receptors for the 4 basic tastes: sweet at the tip, salty and sour along the sides, and bitter at the back. You may even have been asked to reproduce this map by dripping various substances such as salt water, sugar water, and lemon juice onto different parts of your tongue, and gotten frustrated and even failed the assignment when the results of the experiment failed to match up to the diagram, making you forever bitter and causing you to turn your back on the entire institution of science and miss out on a potentially brilliant career and the prospect of a Nobel Prize. Maybe. Well, there's some good news. Turns out you were right all along. The tongue map, a fixture of science textbooks for nearly 100 years, is in fact just total nonsense. Not only are the tongue's taste receptors not divided into these neat little zones, but we now know that there are in fact more than just 4 basic tastes. Furthermore, scientists have known this for nearly 50 years. So how then has this patently false map persisted for so long? Well, it all has to do with an unfortunate scientific misunderstanding. In 1901, German scientist David P. Heinig published a paper titled The Psychophysics of Taste. In it, he described an experiment wherein he applied substances representing the 4 basic tastes: sucrose for sweet, quinine sulfate for bitter, dilute hydrochloric acid for sour, and salt for salty. And he did this to different regions of his subjects' tongues in order to determine the stimulus threshold, that is, the minimum amount of a substance required for the subject to perceive the taste for each region. This experiment revealed that the stimulus threshold varied slightly but significantly across the tongue's surface, being lower on the outer edges of the tongue and increasing towards the center. The threshold variation was also different for each of the 4 basic tastes. For instance, the threshold for sweet was the lowest at the tip of the tongue and increased moving rearward. Heinig published these results in a handy graph showing the change in sensitivity, that is, the inverse of the stimulus threshold, to each taste across the different regions of the tongue, and there it remains for more than 4 decades, unknown to all but few specialists in the field of psychophysics. Fast forward to 1942 and the publication of the textbook Sensation and Perception in the History of Experimental Psychology by American psychologist Edwin G. Boring. Despite his name, Boring enjoyed a long and fascinating career in the field of experimental psychology. Among his many achievements, in 1930, Boring popularized a cartoon by cartoonist W.E. Hills that could either be perceived as an old or young woman, with the viewer's brain constantly switching between the 2 interpretations. Boring used the cartoon and others like it to study the brain's responses to ambiguous stimuli, leading to such illustrations becoming known as Boring figures. Boring also conducted experimental studies on the moon illusion, the common perception that the moon is larger when it's close to the horizon than when it is higher in the sky, as well as an amusing 1917 experiment in which he woke up sleeping subjects and asked them to guess what time it was. Amazingly, while Boring found that many people could not carry out this task at all, those that could often guessed within 15 minutes of the correct time. In Sensation and Perception, in the History of Experimental Psychology, Boring reproduced and reinterpreted the taste sensitivity graphs from David Heinig's 1901 paper. Unfortunately for Boring and millions of schoolchildren over the following century, Heinig had committed a cardinal sin of data presentation. he didn't label his graph axes properly. This led Boring to misinterpreting Heinig's data in two fundamental ways. First, he assumed that the lowest values on the graph represented zero sensitivity to that particular taste, and second, he assumed that Heinig had measured the change in sensitivity of each taste relative to other tastes. Boring's reinterpreted graphs thus gave the impression that the receptors for each of the four basic tastes were concentrated in distinct regions of the tongue, and that each of these regions could perceive only one taste and not others. This seemed to confirm the findings of another German researcher, A. Hoffmann, who in 1875 observed that the center of the tongue had almost no fungiform papillae, the little bumps that cover the tongue, and thus concluded that it must also have no taste buds. This flawed perception eventually led to the creation of the now familiar tongue map, with one of the earliest versions appearing in a 1952 article in Scientific American by A.J. Hagen-Smit. However, it didn't take long for scientists to confirm what generations of exasperated students had long suspected. As early as 1974, experiments conducted by American researcher Virginia Collins revealed that while sensitivity to different tastes do indeed vary across the surface of the tongue, these differences are minor, and every part of the tongue is in fact capable of detecting every taste. Indeed, David Heinig had drawn this conclusion nearly a century before. Not included in his widely misinterpreted graphs was the tongue's sensitivity to the taste of salt, which was not found to vary significantly across the tongue's surface. In addition to debunking Edwin Boring's conclusions, Collins also discovered that taste receptors are not confined to the papillae and are instead found all across the tongue, on the soft palate and at the back of the throat, and even the epiglottis, the flap of tissue that blocks food from entering the windpipe. Other researchers have also discovered taste receptors throughout the digestive tract, although these are not capable of producing a conscious sensation of taste and are likely used to regulate the digestive process. There are plenty of other findings which similarly debunk the traditional tongue map. Signals from the taste buds are transmitted to the brain via two cranial nerves: the glossopharyngeal nerve, which connects to the back of the tongue, and the chorda tympani, which connects to the front. If taste receptors were actually arranged as the tongue map suggests, it would follow that damage to the chorda tympani would eliminate one's ability to taste sweetness. However, in 1965, experiments by surgeon T.R. Bull revealed that this was not the case. Likewise, in 1993, researcher Linda Bartoshuk of the University of Florida discovered that anesthetizing the chorda tympani did not interfere with the subject's ability to taste sweetness. In fact, it actually caused them to perceive the taste even more intensely. And as if this wasn't definitive enough, both Boring and Heinig were wrong on yet another count. There are, in fact, more than just four basic tastes. One day in 1907, Kikanai Ikeda, a professor of chemistry at Tokyo Imperial University, was eating dinner with his family when he noticed something odd. The dashi broth in his soup tasted richer and more flavorful than usual. After stirring his soup for a few moments, Ikeda realized that the flavor enhancement was caused by the addition of kombu, a type of seaweed, and katsuobushi, dried fish flakes. This led Ikeda to theorize that there was a fifth basic taste in addition to sweet, sour, salty, and bitter, which he dubbed umami. Within a year, he succeeded in isolating the kombu from the chemical responsible for imparting the umami flavor, monosodium L-glutamate, better known as MSG. In 1909, Ikeda developed and patented a process for mass-producing MSG from wheat and soy, and founded Ajinomoto Co. Incorporated, the name being derived from the Japanese for essence of flavor. Today, Ajinomoto is a multinational empire that employs over 32,000 people and generates nearly $10 billion in annual revenue, while MSG is one of the world's most popular flavor enhancers alongside salt and pepper. In addition to pioneering the mass production of MSG, Ikeda also studied other foods to determine if they also contained glutamate, and discovered high concentrations in meat, seaweed, and tomatoes. This led him to theorize that humans evolved taste receptors for glutamates because they often signal the presence of proteins, a vital component of an omnivore's diet. While for many years the existence of umami had been hotly debated, especially in Western circles, it has since come to be accepted as the fifth basic taste, with its perception acting as a signal for the digestive tract to produce protein-digesting enzymes. More recently, researchers have also posited the existence of a sixth basic taste, stimulated by pure fats. However, the receptor for this hypothetical taste is yet to be identified, while laboratory tests have revealed that while test subjects can identify the presence of fat under conditions of forced choice, most cannot consciously perceive it as a distinct taste. This suggests that, like with the taste buds in the lower digestive tract, our perception of fat may be a case of so-called blind taste. To Today, the anatomy of the tongue is far better understood than in Edwin and Boring's day. Most taste buds are clustered on bump-like structures known as papillae, of which there are three basic types. Button-shaped fungiform papillae, mostly found on the tip and outer edges of the tongue, ridge-like circumvallate papillae, mostly found on the rear of the tongue, and foliate papillae, found in trenches along the rear sides of the tongue. These papillae typically hold around 4, 200, and 120 taste buds respectively, with the average human mouth containing around 8,000 taste buds. Each taste bud, in turn, holds between 50 and 100 taste receptors, with each of the 5 basic tastes, or 6 as the case may be, being detected by a different type of receptor. As previously mentioned, individual taste buds and receptors are not confined to the papillae and are found all over the tongue and mouth. While the receptors for the 5 basic tastes are distributed more or less evenly over the surface of the tongue, meaning that you can perceive sweetness and bitterness just as easily on the back of your tongue as on the tip, and saltiness and sourness in the middle of the tongue as on the edges. Indeed, from an evolutionary standpoint, this does make good sense. For example, bitterness often signals the presence of toxins. If only the back of the tongue were able to perceive it, it would have placed our evolutionary ancestors at a much higher risk of being poisoned. It's now known that not all animals perceive taste in the same way. Humans, for example, evolved to taste and seek out sweetness because sweet food, like ripe fruit, provided a concentrated source of calories. Obligate carnivores, like cats, by contrast, do not eat fruit and thus did not evolve to taste sweetness. This means that while Mr. Whiskers may love to lick your ice cream cone when you're not looking, he's probably in it for the protein in the cream, not the sugar. So, in light of all this contradictory evidence, why then has the tongue map persisted for so long? The most likely explanation is that we humans like order and organization, and the elegant simplicity of the tongue map appeals to these innate preferences, especially when it comes to the sometimes difficult task of teaching science to children. As Linda Bartoshuk noted in 1993, the apparent simplicity of the tongue map has made it a popular laboratory demonstration in children's biology classes. The popularity of this laboratory demonstration is particularly amazing, considering that it must fail to produce the expected results quite regularly. However, there may still be a grain of truth behind the discredited tongue map, for more recent research has revealed a small but significant variation in sensitivity to different tastes across the surface of the tongue. For example, bitter and umami tastes, as well as the heat generated by capsaicin, the active ingredient in chili peppers, is more easily perceived at the back of the tongue than the front. But again, this difference is so small as to be all but insignificant in everyday life. So in conclusion, should you happen to run into your 8th grade science teacher in the grocery store produce aisle, you can now loudly inform them and the rest of the shoppers carefully testing the ripeness of avocados that you were right and they were wrong, and that your failing grade was an affront to the integrity of the scientific method, damn it. You can then watch smugly as their expression growing progressively sour, they slowly lay down their umami-laden fruit and begin to cry salty and bitter tears of defeat, all the while reveling in the old adage, revenge is sweet. Thanks again to War Thunder for sponsoring today's video. Remember to follow the link in the description below to start playing their free vehicle combat game with 3 free days of premium play and a free premium tank as well. Go check it out, and thank you for watching.